Everyone, today we will be doing the chapter Exponential Growth and Decay. It is for managing money. Okay, chapter 17, and our key focus area would be exponential growth and decay. See, for example, you have three offers. These are the three deals in front of you. I want you to pause the video and think and answer which deal is the best. Okay, this would be just a starter activity for you all. Okay, just for your reference, after you're done, deal 3 is the best. You need to write in your comments and ask me questions in case you have any doubts on this. Let's start. We're going to learn about exponential growth and decay. What is exponential growth? What is decay? See, whenever a quantity increases in a fixed proportion at regular intervals, that means every 2 months, every 3 months, every 6 months, or every year. So if a quantity is increasing in a fixed proportion at regular interval, the growth is said to be exponential growth. Okay. And if the quantity decreases in a fixed percentage, it should be fixed percentage over regular period of time, then I say it is exponential decay. So if it is increase, it is exponential growth. If it is decrease, it is exponential decay, but it should be fixed proportion, regular intervals. So your formula for your exponential growth would be A, Y will be A 1 plus R the whole raised to N. Okay, R would be the rate of interest, N would be the number of years. And for the decay, instead of the plus, you put the minus. A is your original value, or I would say the principal amount. R is the rate of change, whether it is increasing or decreasing at what percentage, because it should be fixed percentage. And N is the number of period. Let's start with a worked example. You say, before that, try to recall the formula of exponential growth. Your value, the main amount, or your y is equal to A 1 plus R the whole raised to N. Now, say for example, $100 is invested subject to compound interest at 8%. Find the value of the investment after 15 years. That means my investment is increasing at a fixed percentage. Okay. And you have to calculate the value after 15 years. So you use the formula for exponential growth. Your value would be A 1 plus R the whole raised to N. R is 8. So 8% is nothing but 0.08. Okay. So 8%, 1 plus R. So 1 plus 0.8. So 1.08. Okay. 8% is 0.08 and you add 1 to it. So 1 plus 0.08 is 1.08. So A is your amount invested into bracket 1.08 the whole raised to 15. What do you get? Bracket 1.0 the whole raised to 15. So the value of your investment after 15 years, it's exponential growth. It is going to be $317.22. This is to the nearest cent. Okay. Let's take the other example. Now here your computer system depreciates. That means the value goes down by 30% per year. Here, the value of your new computer is depreciating by 30%. What is exponential decay? Okay, the quantity is decreasing by a fixed percent over the regular period of time. So the quantity is going to decrease by 30% for a regular period of time. So this is exponential decay, and the formula for it is A 1 minus R raised to N. It's 30%. So the 1 minus R, okay, 30% is 0.3. You can check over here. 1 minus 0.3 is going to be 0.7%. 0.7. The whole raised to 2. I want 2 years time. So value of my new computer would be 1200, 0.7, the whole raised to 2. After 2 years, value would be, again, later, $588. Okay. Now this one for you to try. Value depreciates by 15% and the car was bought for 18,000. So this is exponential decay. So the value for the first 3 years, what is the value at the end of 3 years? It would be A 1 minus R raised to N. So 1 minus 0.1 is 0.85. Okay, so it would be 18,000, 0.85, the whole over 3. Plug in your computer, sorry, calculator. So the value would be pound 1105.423 at the end of 3 years. Have I done some mistake? It's 18,000. So 1105.425 pounds. Now this is a past paper problem. You can pause the video, try, and then come back. Let's go to the next one. There are 30,000 lions in Africa. The actual number of lions you want Y is equal to 1 plus R raised to N. A. 30,000 lions in Africa. This is your actual number of lions. So A would represent 30,000. And it decreases exponentially. So instead of plus, I will put a minus. Okay. So 1 minus 2% each year. I want to find the number of lions in Africa after 6 years. So 2% would be 0.0 and minus, so it is 0.98. So number of lions in Africa after 6 years would be 30,000 into 0.98, the whole raised to 6. So it would be 26,575.27, but lions cannot be in points. So the number of lions in Africa could be 26,575 or 26,576. They wanted to the nearest 100. So the nearest 100 would be 26,600 lions be there in Africa if it decreases exponentially by 2%. Now let's take the next sum. You have a city. The population is increasing exponentially at the rate of 1.6. Find the overall percentage increase at the end of 20 years. Now, please note over here that you need a percentage increase after 20 years. So, you need the increase or decrease of the population over your original population into 100 to get the percentage increase of population at the end of 20 years. So, you have a city, population is increasing exponentially. Okay, so your population after 20 years would say BP, and T0 is your old population. It is increasing exponentially, so 1 plus R over N. Okay, let's take the R. 1.6% it is increasing. If you divide this by 100, so this is becoming 1 plus 0.016 plus 1. So it will be 1.016. So I don't know my old population, the original population, but the population is increasing by 1.6% per year. So P0 is the original population and P is the final population. Now this would be 1.016, the whole raised to 20. Okay, the whole raised to 20, and this is the final population. I want percentage increase at the end of 20 years. Percentage increase would be what? My original population, my final population minus 100, I would get my percentage increase. Think about it. So now over here, I don't know my population, the original population that has increased. So now we will say, for example, say our original population was 100. Okay. So after 20 years, this population has become how much? Exponential growth. So if I say 100 after 20 years, this population has become, after 20 years, this population has become 137.364. So what is the change in the population? The change in the population would be how much is has increased over the original population into 100. So it has increased by 37.364 over the original population that was 100 into 100. So my percentage increase would be 37.36 percentage. So what is the overall percentage increase? So my overall percentage increase is 37.36%. Let's take the next question. Population of the village is 6,400. Okay. So this would be my final population and the initial population P0. I say this is 6,400. Population is decreasing exponentially. So I would say it is 1 minus R raised to N at a rate of R% per year. After 22 years, that is means my N is 22. The population will be 2607. The main population will be 2607. Find the value of R. I need to find the value of R. If I want to find the value of R, means I need to make R as my subject. How do I make R as my subject? Think. So I need to find R. I need to make R the subject. So first thing I'll do, I will divide both the sides by 6,400. So if I'm dividing both the sides by 6,400, so on the left hand side, I'm going to get 2607 divided by 6,400. So this is going to give me 0.4073437 is equal to 1 minus R 22. Now I need to make R separate. So I will take the 22nd root of this. So what do? I this. I want root. I have this function which is like this. So if I want root, I will press shift and this, so it will be in root. So 22nd root of 0.407343775 is 1 minus R. So 1 minus R would be equal to 0.959. So I can say this is equal to 0.96. Now since my 1 minus R is equal to 0.96. So just give me a minute. So 22nd root of this would be now what I would do is I need to make R the subject. So I would minus 1 from both the sides, or I will minus R from add R to both the sides. So this would become R plus 0.96 is equal to 1. Now we'll minus R from both the sides, or we'll minus 0.96 from both the sides. So R is equal to 1 minus 0.96. So R is an approximate figure. What is the value of R that I'm getting? So I'm getting the value of R as, let's check again, the 22nd root of 2607 divided by 6,400. So we are getting 0.95 or 0.96, that's okay. So R is approximately, whatever is my answer. So R is approximately how much? 0.04. Now I want to convert this into percentage. So how do I convert this into percentage? To convert this into percentage, you do nothing but you just multiply this by 100. So you have 0.34 into 100. So it is 4%. So the value of R is 0.04. Okay. Population is decreasing exponentially at the rate of 8%. So the percentage at which the population is decreasing is 4%. Now you have this short plenary for yourself. You have to test yourself. Try to do it yourself. I'm sure you will be able to do it. You have population of microbes in a laboratory. It doubles every year. At the start of the period, the population is estimated to be 1 million microbes. So at the start of the period, that means when it was 0 days, the population was 1 million microbes. Complete the table to show the growth in microbes. So it's going to double every year. So this will become 2. 2 square is 4. 4 square is going to be 8. It is going to double every year. Okay, 4 square is nothing, it's 16. Then 16 square is 256. 256 square is 65,536. So it is going to double every year. You have to complete the table and show the growth in the population.